Good morning, children. This is anyone working in the Pharaoh group. Before we start today's learning, please do your 10 minutes on TT Rockstars to begin with. Thank you. So today's learning, children, we're going to find the area of irregular shapes. I mentioned the word irregular, the phrase irregular shapes yesterday, and I used the term a puddle to sort of picture it. And this is what I mean by what an irregular shape is. As we can see, this shape doesn't entirely fill up all the squares. And we're trying to find the area. Now, to find the area can be it's very difficult to get it accurately. So we use approximations, estimations on what we think the area is. Now, it says here, if each square represents 1 meter squared, which is the best approximation of the area of this shape? The first thing what you could do is work out how many full squares there are. So we've got 1, 2. If we look here, we've got a little bit left there and a little bit left there. And we could say that this section here fills in there and that bit could fill there. So that would be another 4 full centimetre squared shaded in as the area. And we said we use that bit and that bit. We do have this bit here left. Okay, so we know it's not going to be 4 meters squared. 10 meters squared would be a proportion that big. 6 centimeters squared would be that big. And you can use this way to actually identify by making, if you visualization, so if we were to say this is 6 meters squared area and this was a 10 meter squared area, what is the more likely of that puddle fitting in? Is it going to be in an area that big or in an area that big? And as you can see, that we can easily see that this, we've got 2 fully shaded in squares, and we've got 2 here that are very close. This here is approximately close, which is, so give us 5 meters squared. We haven't got enough to make 10 meters squared. So 6 meters squared would be the best approximation. True or false is the second question. If each shape represents 1 centimeter squared, this shape has an approximate area of 6 centimeters squared. So as I've said before, the first thing you want to do is identify how many full squares there are. So we've got full square there. 1, 2, 3, 4. So we know we've got 4. We've got to work out the rest, whether this makes about another 2 centimeters squared to make 6 in total, or is it greater? So we can see if we had this here is a bit bigger than that. So we know that this could give us number 5 using those 2. Here, we could say that this section here matches to there, which is 6. And that this section here could go there. Again, it's approximation, so that's 7. And we've got even half left here. So is this could this area be approximate area of 6 centimeters squared be correct? Probably not, because as we can say, it's great. We've got at least 7 here, which is greater than 6. So the answer is false. Last one here again. Each square represents 1 centimeter squared. Is the approximate area of the shape more or less than 9 centimeters? So let's see how many full squares we've got again. So we can say that this is a full square. 1, 2, 3, 4, 5, 6, 7, 8. Now straight away, I can see, children, we've got lots left. And there's going to be a lot more than just 9 here. Because even if this here has just got a little bit remaining, or even if we had a little bit from one of these, this bit here, that will give us 9. We've still got this section here, here, all round here. So we can say straight away that this answer is more. 1B. And this is going to be our reasoning and problem solving. Each square represents 1 centimeter square. How many centimeters squared would you have to add to the smaller shape to make it approximately the same size as the larger shape? So each square represents 1 centimeter squared. So this here is the smaller shape. Okay, So let's see how many we've got here. So we've got 1, 2, 3, 4, 5, 6 whole. And if we were to say that these two here make a hole, so that's 7. These two here make a hole, that's 8. And if we had these 3 together, they make another hole. We've got 9 centimeters squared, approximately. Let's see how many we've got a hole here. We've got 1, 2, 3, 4, 5. I would say roughly 5. So if we've got 5 centimeters here approximately, how many would we need to add to get to 9? So it's 5 plus a number equals 9. And that answer would be 4 centimeters squared. We'll look at this question here. Each square represents 1 meter squared. Ava estimates the shape area to be 7 meters squared. Is she correct? Explain your answer. So we remember how many full squares we've got. We've got 1, 2, 3, 4. We could say that this section here could fit in there. So that could be number 5. And the same here, 6 could go there. And then we've got this section here. So we've got 6 so far. Even though we've got a little bit missing here, and that doesn't give us a full representation, we could approximately say that Ava's answer is 7, because it is a lot closer to being 7 meters squared rather than 6, because there's quite a lot of the 7th box has been filled. So to explain this, a way that we can write this down into our books is that we could just say this approximately covers 7 meters squared, and that would be perfect to explain your answer. Now this is going to be quite a fun one for you to do. Each square represents 1 centimeter squared. Draw an irregular shape that allows with an approximate area of 8 centimeters on this grid. Now, as I've said before, a lot of these have whole squares already. So what you want to do is I'm going to take 3 whole squares, and I'm going to shade these in now. So I've got 1, 2 there, and I'll do a third there. I want to approximately make 8 centimeters. So I've got 3 there, so I could do a little bit. I'm just going to use this pencil to draw my shape. So I've got quite a full one there. So I might just do a little bit there. So I could say that this gap there would make that section there. So we've got 4. And it's good to keep a running total in your head so you identify. We could say that this part here and this part here will make 5. So we've got to make 3 more. So if we were to do that, could be 6 because there's a little bit there. We need 7. Could be there. And if we go halfway up, like a curve, we could say, let's do that a little bit. And that could be our regular shape. And just to show, we've got 1, 2, 3, 4, 5. We've got the 6 there, the 7 there, and then the 8 are these 2 together here. Have a go at doing that. That's a very sort of challenging question to do, but one that allows you to be creative with your answers. Once you've done that question, please then go on to do some extra practice on IXL where you create figures with a given area. Best of luck.